Hello students, welcome to the next lecture on conventional manufacturing processes, and in this lecture we will discuss about the shaper machine numerical problems. So in this session you will understand how to find the machining time calculation and the material removal rate. So let us start with the first example, and as I have explained to you in all the numerical sections that first you need to find which data is given and what are the required answers that is expected from you from this question. So here, as you can see, the first and foremost thing they have asked is to calculate the machining time. So what is the main important thing required? That is to calculate the machining time, right? And for this the given data is over here. Let us write that. So first, workpiece data is given, and we know that workpiece data, that is 200 by 300. This is nothing but the length by width data, right? So here the length of the workpiece, that is 200 mm, and the width of the workpiece, that is 300 mm. Now another data given, that is the return speed is given over here, right? Return speed is given, that return speed is 20 meter per minute, and the cutting speed is also given, and the cutting speed is, it is given over here, right? That is 10 meter per minute, and the feed is given, the given feed is 5 mm per full stroke. So what is this full stroke indicates? This full stroke is nothing but the double stroke. That means the summation of the cutting stroke plus return stroke. Because after completion of the cutting and return stroke only, the one entire total full stroke gets completed. And the clearance given over here, that is the 50 mm. Now what we need to find? We need to find the main important data that is required for machining time. So we need to find the machining time. Now how we will find machining time? So for that, first let us find the total length traveled by the tool during machining operation. So the total length travel, that will be what? Total length travel will be the length of the workpiece, that is 200, plus the clearance given on each side. At each end the clearance is given, that means we must need to add the clearance also, that means 200 plus 2 into clearance is given 50. So now the total length traveled by the tool during machining, that is what? That is 300 mm. So that is the first data required. Now here we know that in shaper machine the main operating mechanism is what? That is the quick return mechanism. So for that, and we know that the cutting stroke, and in the case of the cutting stroke and return stroke, cutting stroke is slower because during this process the cutting is taking place, but during the return stroke it gets into its returned position very quickly. So we know that the quick return ratio, that we can get easily from the data of which we require the data of the cutting velocity and the return velocity. So here for the calculation purpose we will define one important another term, that is m, and that is nothing but the reciprocal of quick return ratio. So that quick return ratio you will write as velocity of cutting stroke divided by velocity of return stroke. So what is the velocity of cutting stroke? That is 10 divided by 20. So we will get the value of m as the 0.5. So now we got the value of L and we got the value of m. Now how to find the cutting time? We know that velocity is equal to what? Velocity, that is equal to distance traveled divided by time taken. So using this same formula we can find the cutting time. Cutting time, that is nothing but the distance traveled by the tool, that is the total distance traveled, that is L, divided by the cutting velocity that already given. So L that is given is 300. Right now we got the value by adding the clearance, that is 300, and the cutting velocity or the cutting speed that is given is 10. But here this 300 is in the form of the mm, whereas this 10 is in the form of the meter per minute. So we need to convert it into the mm. So we will multiply this by 1000. So this value becomes mm per minute, right? So the cutting time that we will get, that is the 0.03 minute. So this is the cutting time obtained. So now just remember over this value, we have find the total length traveled, we have find the value of m, we have also the value of cutting time. Now which value we required? Now we required return time, that how much time the tool is taking to return to its original position. So we know that from here m is the ratio of what? Velocity of cutting stroke divided by the velocity of return stroke. So using this same logic, we can find the velocity or the total time taken for the return stroke also. So how we can get that? So easily, m can also be written as, you can see over here, m can also be written as, we know that velocity is reciprocal of the time, right? Velocity is the reciprocal of the time because distance traveled is same in both the cases. So m can also be written in the form of time for return stroke divided by time for cutting stroke. So now we need to find the time of return stroke. So how we can find time of return stroke? So time for return, that is equal to m into time for cutting. So now using this simple equation, we can also find the time required for the return stroke. So now we will find the time required. So time required, that is the value of m we got as 0.5 multiplied by the time for cutting. So time for cutting, that is 0.5 into 0.03, that is 0.015 minute. So now the total time required for the full stroke, total time required, that is what? Time for cutting plus time of return. So time for cutting is what? That we have already find, that is 0.03, and this is 0.015. So the total time required, that is 0.045 minute to complete one full stroke. Now we know that here the width of the component, that is the 300 mm, and for each feed it is machining the 5 mm of the component. So for one entire cycle of the full stroke, how much material can be removed? That is the 5 mm 5 mm feed is given, that means the 5 mm size out of the 300 that can be machined easily. So how many number of cycles that we need to repeat these shaper cycle or the shaper operation so that we can machine entire given workpiece? So the total number of cycle required, number of cycle required, that are, how much we need to machine? 300, and per stroke we are machining 5 mm. So that means the total number of cycle required to perform the complete operation, that are 300 divided by 5. So that is nothing but the 60. So 60 number of cycles are required, means 60 number of double strokes are required to machine the entire workpiece. So now total time required, this time that we obtained, it is for what? For single full stroke. Now the total time required, total time required is what? That is total number of cycle multiplied by the time taken by single cycle, that is 0.045. So When you complete this, you will find the answer as 2.7 minute. So that means the total time required to machine the given workpiece, that will be the 2.7 minute. So this is your final answer. Now, this is the standard logical procedure using which you can find the total machining time if you do not remember the exact equation available to find the machining time. But there is one standard equation is also available to find the machining time for the case of the shaper machine. So what is that? Let us write that. Now, the total machining time required, that is the L into W 1 plus M divided by 1000 into cutting velocity into speed, and the answer you will get in minute. So we know that the value of length, that is the 200. Now here clearly keep in mind that here this is the value of L. Do not make the mistake for this. We need to consider clearance also. That means we need to use 200 instead of 200. We need to use what? Total length traveled, that is 200 plus 2 times clearance. So the length to be traveled, that will be 300 mm. So here we will use the value 300. Now the width, that is also given as 300. Now 1 plus, we already found the value of M, right? M is nothing but the ratio of what? Cutting speed divided by the return speed. So that will be 0.5 divided by 1000. Now we know the cutting velocity or the cutting speed, that is 10, and the feed given, that is 5. Now when you solve this numerical data, you will find that the value of machining time that you will get, that is also 2.7 minute. So you can use this equation also to find the machining time, but if you do not remember the equation for this machining time, then you can use this standard procedure that we have discussed earlier. So I hope you got the clarity how to find the machining time required for this particular case. Now let us take another example in which we need to find the machining time also and the material removal rate also. So in this second, similarly, first we will write all the given data and then we will check which file, which data we need to find. So here it is mentioned that estimate the time required. That means we need to find the machining time required. So this is the first case required. Here given surface 250 mm long. So length given, that is the 250 mm. Width given, that is the 150 mm. Now cutting to return ratio, that is given as 3/2, and we know that we need to find the value of M also, which is what? That is the reciprocal of the quick return ratio. So you will find 1 divided by QRR, that is equal to 2 divided by 3. So here we have rounded up to the 2 decimal points. So we find the value of 0.67. Now another cutting speed is also given, that is 21 meter per minute. Feed is also given 2 mm per stroke. Clearance is given 25 mm, and the depth of cut given also over here, depth of cut given as 4 mm. So here we know that when the clearance data is given, now we need to find the total travel length of the tool. Now how we will find that? We have already seen that total length traveled, that is the length of the workpiece plus 2 times clearance. So length of the workpiece, that is 250, and the clearance given, that is 25. So 250 plus 50, you will find the total travel length, that is the 300 mm. So up to now, I think it is clear to you now. Now next, we will find the value of N, because we know that to find the machining time, the standard equation available, that is for the case of the shaper machine, that is the F divided by N, right? So here we need to find the value of N, and this value of N we can find easily by using the equation of the cutting speed. So the standard equation available for the cutting speed, that is Vc, that is equal to N number of stroke into length divided by, into multiplied by 1 plus M divided by 1000. This small m is nothing but the capital M, that is the reciprocal of quick return ratio. So cutting speed that is given 21. We need to find the value of n. L we have already found, that is 300. 1 plus m also we have found, that is 0.67 divided by 1000. So why we are finding the value of n? Why we are not considering the standard equation available for the machining time calculation? Because here they have given the standard strokes available for the shaper machine. That means we need to select from the standard strokes only. If they have not given the standard strokes available, then we can move forward with the standard equation of the machining time that we have discussed earlier. But here they have given the available ram strokes and we need to use from these only, because as you can see here we are getting the value of n, that is 41.92 strokes per minute. But we need to use the standard strokes data available. That is, we can see that this value is nearer to the value of what? Here from 28, 40, 60 and 90, this value is nearer to the 40. So we will select the 40 strokes per minute for machining of our workpiece. And due to that reason only, we are not using the standard equation available for the machining time. Because if you use the standard equation available, at that time you will find the machining time required that will be different. So here now we are getting the value of n from the standard data available in the example, that is the 40 strokes per minute. So now to find the machining time, what we will do? We will directly use this equation W divided by F, and now we have the value of width available, we have the value of feed available, now we have also find the value of F. So now as you can see, the machining time required, that is W divided by F into N. Now width of the workpiece is what? That is 150 mm, which is mentioned over here. Now the value of N we have already found, that is 40, and the feed available, that is mentioned over here, 2 mm per stroke. So that is also given over here. Now when you solve numerically, you will find that the value of machining time, that is 1.88 minute, and this is the answer for your machining time required. Similarly, we also need to find the material removal rate, which is asked over here. So how to find the material removal rate? So for that, one standard equation is available. Feed into depth of cut into length of the total length traveled by the tool into n, that is the strokes per minute, in bracket 1 plus m. This is the standard equation available to find the material removal rate. So here the value of feed is 2, depth of cut given, that is the 4, right here mentioned. L we have already found, that is 300, and we have already found, that is 40, into 1 plus m value is also available. So when you solve the value numerically, then you will get the answer as 1,60,320 mm³ per minute. You need to clearly understand that here by using all this data you will find the MRR in the case of mm³ per minute. So unit is also important. You also need to mention the unit at the end of each and every calculation, because if you do not mention the units, then it will also deduct your marks. So the unit representation and the proper unit representation, that is also important. So I hope now you got the clarity how to find the machining time. So for the machining time, in the case of the shaper machine, the standard equation available, that is W divided by Fn, and for the case of material removal rate, the equation available is F into depth of cut into length traveled into strokes per minute in bracket 1 plus m. So these are the standard equations that you can use to solve for the machining time and the material removal rate required. But you need to clearly understand that if the standard available ram strokes are mentioned, then you need to use these and these equation only, because the value of n will vary according to the given data. So I hope now you have the complete clarity how to solve the numericals given for the case of the shaper machine, and this same method is applicable for the slaughter machine also. So looking forward to see you all in our next lecture. Up to then, thank you.